Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zulilman bin Muhammad Ghazali. I am a student of Automotive Mechanical Engineering student from UMP. So today I will explain a bit about engine support system. In engine support system, we have 6 components, which is number 1 fuel injection and fuel line system, number 2 exhaust system, number 3 air intake system, number 4 supercharger and turbocharger, number 5 engine cooling system, and number 6 engine lubrication system. So let's go through one by one. Fuel injection system. So what does a fuel injector do? A fuel injector delivers the mixture of fuel and air to the engine cylinder. It also controls the consistency of the amount of fuel being sent to the engine across all cylinders, while preventing inconsistent power delivery. This diagram shows how the fuel injection system works. So the fuel injection is fed by the fuel rail. Pressure from the fuel pump forces the fuel into the injector from the fuel rail through a small filter inside the injector. This diagram shows the component of a fuel injector. So we have valve spring, plunger, spray tape, solenoid, fuel filter, and also the electrical part of a fuel injector, which is connected to the computer. These are some of the examples of a standard petrol electronic fuel injectors. Types of fuel injection system. Number 1, throttle body injection or TBI, also called central fuel injection. TBI emitted fuel better than a carburetor but not as precise as MFI and CMFI. Number 2, multi-port fuel injection or MFI. It is an individual injectors with poppet valve. Number 3 is sequential fuel injection. In sequential fuel injection, it opens each injector just before its intake valve opens. Each injector has its own computer connection. Computer completes the ground for each injection in sequence. Number 4, port fuel injection system. It injects fuel into the intake port of the engine before the intake valve. Number 5, direct fuel injection, which it injects fuel directly into the combustion chamber. Direct injection and indirect injection. What is the difference? So in indirect injection, chamber is divided into 2 regions and the fuel is injected into the pre-chamber, which is connected to the main chamber via a nozzle or one or more chamber. In direct injection, have a single open combustion chamber into which fuel is injected directly. Limitation of fuel injection system. High initial cost, requires special servicing, special knowledge of mechanical and electrical system needed to diagnose and rectify faults. Injection equipment complicated means it complex and delicate to handle. Then it contains many mechanical and electrical components. It also increases hydraulic and mechanical noise due to pumping and metering of fuel. The last one will be extra careful filtration required. So in summary, the fuel injection system needs a meticulous care to for the system to function well. This diagram shows the measurement of quality of injection. So the fifth one shows the ideal condition of a fuel injector, while the other are the bad ones. Next one will be fueling system. Fuel delivery system component consists of fuel storage tank, fuel pump, fuel filters, and fuel lines, hoses, and fittings. Fuel storage tank. So a fuel tank can hold up from 30 to 100 liters. It is from a corrosion resistant galvanized steel. The baffle prevents fuel sloshing in tank. Cluster assembly includes pickup tube, fuel gauge, fuel pump, and fuel sending unit is installed at the top of tank. In-tank filter is installed at the end of pickup tube, and the tank has expansion and overfill protection. Fuel pump. Fuel from pump flows in a fuel rail loop between engine and fuel tank. electric fuel pump has one-way check valve that maintains pressure when engine is off. The fuel pump is submerged in well of fuel. Next will be fuel filters. It is located on outlet side of fuel pump. It filters out smaller particles of dirt while allowing pump to supply fuel. The next one is fuel lines, hoses and fittings. It is a steel lines made of seamless tubing, run the length of the frame as shown in the picture. Its sole purpose is to transport fuel from tank to engine, and hoses used for flexible connection. We're going through intake and exhaust system. So function of air intake. It is to allow air to reach your engine. Oxygen in the air is one of the necessary elements for the engine combustion process. On most modern vehicles, the intake system consists of a plastic air box which housing a paper air filter. Engine vacuum produced by the downward movement of the piston on the intake stroke brings air into the engine cylinder. The amount of air entering depends on the cylinder's ability to form a vacuum and intake's ability to fill the cylinder, as shown in the picture. You can see the air coming from the left intake port inside the cylinder, which of course happens when the piston moving downward, which then creates a vacuum inside the cylinder, and the whole process happen. Air induction system. So the system directs and filters out air into the cylinder. It also makes sure intake ductwork is properly installed and all connections are airtight. Air leaks after the airflow sensor will cause drivability problems. Next, air filter or air cleaner. Its primary purpose is to prevent airborne contaminants and abrasive from entering the engine cylinders. As shown in the picture, that is an example of a air filter system. Intake manifolds. Intake manifolds distribute the clean air or air-fuel mixture as evenly as possible to each cylinder. The thermostat and EGR or exhaust gas recirculation are also attached here. The design of an intake manifolds vary by engine type. Turbochargers. So how does the turbochargers work? The exhaust gases spin the turbine blades. Then the turbine turns the compressor wheel. Then air is compressed and sent to the cylinders. And then the turbine spins at very high speeds, and then the wastegate controls the pressure of air delivered to the cylinders. The process typically begins to compress air around 2000 engine RPM. These are types of turbocharger. Number 1, single turbo, twin scroll turbo, variable geometry turbo, variable twin scroll turbo, and electrical turbo. These are some of the turbo manufacturers, such as Garrett, Borg Warner, IHI, MHI, Holset, Honeywell, and Mallet. These are the company that manufacture the turbo. Some of them. We're going through engine cooling system. So the diagram shows how a common engine cooling system works, as you can see. Next, the components of engine cooling system. Number 1, water pump. The water pump said to be the heart of engine cooling system. Water pump has a radial impeller inside its casing, which is driven by the engine itself. Serpentine belt is used to deliver rotational motion of engine main pulley to the water pump pulley. Number 2 component, radiator. Radiator acts as a heat exchanger for an engine. It is usually made up of aluminum and have lots of smaller diameter pipes with fins mounted on them. It exchanges the heat of hot water coming from engine with surrounding air. Number 3, thermostat. Thermostat acts as a valve for coolant and allows it to flow through radiator only after exceeding a particular temperature value. A thermostat has a paraffin wax in it, which expands at a particular temperature and opens it up at that temperature. The last one, coolant temperature sensor. As the name suggests, it is a temperature sensing device in engine cooling system, and it monitors the engine temperature. It provides the data required to control the operation of radiator fan. Engine lubrication system. The engine lubrication system is to distribute oil to the moving parts to reduce friction between surfaces. Lubrication plays a key role in the life expectancy of an automotive engine. So this diagram shows the components of an engine that contributes to the lubrication system. So the benefits of the lubrication system: number one, it minimizes power loss by reducing the friction between the moving parts. It also reduces the wear and tear of the moving parts. It provides cooling effect to the hot engine parts. It also provides a cushioning effect against vibration caused by the engine. It also carries out the internal cleaning of the engine and helps piston rings to seal against high pressure gases in the cylinder. So this list of components are the components that the lubrication system supplies to, as you can see. So these are the types of lubrication system. Number one, petrol system, splash system, pressure system, and dry sump system. These are the major components of engine lubrication system, which comprises of oil sump, engine oil filter, piston cooling nozzles, oil pump, oil galleries, oil cooler, and the last one will be oil pressure indicator or lights. So that will be the end of my presentation. Thank you and Assalamu alaikum.